Yes. So, unit 2. Yes, calm down. Unit 2 is all about the types of instructions. Instruction set of 8051. Instruction set of 8051 microcontroller. So till now we know that the microcontroller is an 8-bit microcontroller. It is having accumulator. It is having B register, and it is having various bank registers. Yes, calm down. Various bank registers. It will have so many SFRs. We can refer to SFRs with their addresses or the names. We know that there are 4 ports, P0, P1, P2, P3. Okay, all these are understood. Means we got an idea about various blocks of the microcontroller with the help of the architectural block diagram. We explored the minimum details of the microcontroller 8051. Now in this particular unit 2, we are going to see how to give an instruction to the microcontroller to transfer the data from one register to another register, how to add them, how to multiply them, how to sort them, how to pick a number, how to flash an LED, how to do various works by giving one instruction after the other. Okay, so instruction is nothing but the command that we are going to give it to the microcontroller. Various types of instructions are there. Okay, all those instructions are classified according to their functionality into 5 categories. So what are the classification? First one is the data transfer instruction. They are used to transfer the data from one to another one. Okay, one register to another register, one location to another location. Okay, so like that. Arithmetic instructions perform arithmetic operations like addition, subtraction, increment, decrement, multiplication, division. All these are arithmetic instructions. Logical instructions, AND instruction, OR operation, and many other operations. Those are logical operations and branching instructions. So branching instructions in the sense you want to change the sequence of the program. Jump if the result is 0, jump if that is not 0, jump if the carry is 1. Simply take a jump from here to there. Okay, make call that particular program, return the result here. All those are the branch instructions. So branch instructions are used to change the sequence of the program. So microcontroller may be executing one instruction after the other. All of a sudden you want it to leave from the present location and take a jump to the new location. Starting from a new location, you want it to execute a set of instructions. That is possible with branching instructions. All these are available in microprocessor also. Okay, they're not new to you. Data transfer instruction move is not new to you. Add is an arithmetic instruction. Increment, decrement, they're not new to you. Okay, logical instruction, end operation, or operation, compare operation. So they are not new to you. We know by their names at least in the microprocessor. But the new variety or completely different set of instructions are bit manipulation instructions. You can manipulate single bit. You can take the decision depending on a single bit. Those sort of instructions are not there in microprocessor. They are not there in this. Jump if the bit is 1, jump if the bit is 0, jump if the result is this thing. So like that, and set this particular bit, set B, clear C. Okay, they are not there in microprocessor. Okay, they are the new instructions that we have come across in the microcontroller. All those are called as bit manipulation instruction or bitwise operations. Okay, bitwise operations. So these are the varieties of instructions that we come across in 8051. Clear? So what are the varieties of instructions? Data transfer instruction, arithmetic instruction, okay, and logical instructions, and then the branching instructions and bit manipulating or bitwise instructions. So these are the instructions. And again, all these instructions are, there is one more concept called as addressing modes. Okay, so addressing mode. um we know what is in by addressing mode. The way in which we are going to, the CPU can access data in various ways, which are called as addressing modes. I may be referring to, I may be referring to one student with their name. I may be referring to the student with their roll number. I already told you, I have given the same examples in the microprocessor also. Your son to your father and mother, your brother to your sister, and your uncle to somebody after you get married. Okay, so you after you get married, you may be father to somebody, maybe mother to somebody, like that. You are uncle to somebody. You will become a grandfather to somebody. So means you are related to many people with many relations, but all are accessing you. Okay, so what are the various ways of accessing the data? That's called as addressing mode. These are called as addressing modes. The main addressing modes are immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, and the last one is the index addressing mode. Index addressing mode. So few things we try to understand them in today's session with examples, and we proceed with the set of instructions. Okay. Now immediate addressing mode. Immediate addressing mode. You take an example, the source operand is a constant. Immediate addressing mode means in the instruction itself, you will find the data. Such addressing mode is called as immediate addressing mode. You can see move a comma hash 25. You are trying to load 25 in accumulator. Move a comma hash 25. If you write that instruction, what happens? Accumulator will be loaded with 25. Move R4 comma hash 62. So 62 will be loaded in R4. Move B comma 40 hash 40. The hash symbol is compulsory. If you don't put hash, that 40 will become the address. Okay, hash 40 means you're loading 40 in B. Move DPTR. Okay, move DPTR. Data pointer register is a 16-bit register. You are trying to load 4521H. 4521H is a 16-bit number that you are trying to put it in data pointer register. Okay, so that is the another way. Another way is, okay, you can load 21 in data pointer lower. DPL means data pointer lower. DPH means data pointer higher. So instead of loading 4521 directly with the instruction move DPTR, you can put 21 in lower, 45 in higher. Clear to all of you? So now coming to the next one, you're not supposed to put any number which is more than 65,535, which is more than 60. I mean, so it's a maximum 16-bit number. Okay, if you are trying to put more than that in a 16-bit register, that is illegal. Okay, you are supposed to, you are asking 10 of your friends to sit in one chair. That is illegal. That is not valid. How can they sit in one chair? So 1:1, one student, if you are asking to sit in one chair, then that is fine. That is legal, right? So what is the capacity of this room? 50. If I am trying to accommodate 70, illegal. All right. So such type of thing this is. So this is the example for immediate addressing mode. Okay. So move A comma 25. 25 will be loaded in A. So coming to the next one. So we know what is by equal to operator, equal to directive. Directive is nothing but it will give you direction to the assembler. It is not an instruction. Okay. So another one, you see DB directive, DB America, something like this. Your DB is a directive, right? Coming to the next one, you can move one number directly onto the port. Okay, you can send one 8-bit number directly onto the port. How you load 25? How you loaded 25 here in accumulator? In the same manner, you can load one number. You can send one number onto the port. You can send one number onto the port. How? Move P1 comma hash 55. Move P1 comma take down. Move hash P1. Move P1 comma hash 55H. You are trying to send 55 onto port P1. What is the instruction to send 23 on port 3? What is the instruction to send 23 on port 3? So what is the instruction? MOV P3 comma hash 23H. So this is the instruction to put 23 on port 3. Okay. So this is an example for immediate addressing mode. Immediate addressing mode. Coming to the next addressing mode, that is register addressing mode. Register addressing mode means data is there in one register. You are trying to transfer that into another, okay, another register. So here move A comma R0, move A comma R0, right? Move A comma R0. So what happens is whatever is there in R0 that will go into accumulator. So data is there in R0, it is going into accumulator. So data is getting transferred from one register to another register. So it's an example for the register addressing mode. Now coming to the next one, add A comma R7. You are trying to add A value with R7. Add A comma R7. You are trying to add A value with R7. Numbers are there in registers. First number is there in A, second number is there in R7, but data is there in R registers. Okay, so this is an example for register, okay, addressing mode. Where is the data? Data is there in one register. Okay, move R6 comma A. Where is the data? Move R6 comma A. Where is the data? Data is there in accumulator. You are transferring it into R6. So that is the, okay, data is there in register. You are transferring it into another register. That's called as register addressing mode. Clear? Now coming to the next one. Here move R6 comma DPH. DPH means data pointer higher. You are transferring whatever is there in data pointer higher register into R6 register. You are transferring the data from one register to another register. It's at a register addressing mode. Coming to the next one is direct addressing mode. Direct addressing mode. See, we know that we know A is an SFR. A is an SFR. Move R0 comma, move R0 comma 0E0. Move R0 comma 0E0. 0E0 means A. How are you referring to A here? With its address, move 00 comma A. How are you referring to the R0 value? with its address move A comma 34H. So 34 is an address. 34 is an address. There is one number available in the 34th location. You are transferring it into A. So here, if I put one hash symbol, what is the difference between the previous one and what great change happened by putting one hash symbol? Anybody? So you changed that 34, earlier 34, it is not preceded with, this 34 is not preceded with hash symbol. So that 34 is an address then. Now if you put one hash symbol, that has become one number. You are putting 34 in A. If I put pound symbol, hash symbol, okay, 34 will come in A. But if I don't put hash symbol, whatever is there in 34th location, that will come into accumulator. Okay, so it just like there is one student available. There is one student available in room number 52. We are transferring them into accumulator. Okay. Now if I put hash symbol, I am putting 52 in A. Okay. There is one student available in 52. You want to transfer it into A. So this is the instruction. If you put one hash symbol, you are loading 52 in A. So hash symbol means you are loading the data in that register. Okay. If you don't put hash symbol, you are putting a number which is there in one location. So this is an example for direct addressing mode. One more example, move P1 comma A. Move P1 comma A. Whatever is there in A, that you are shifting onto port 1. Okay. Move A comma P1. You are shifting port 1 value. You're taking the data into accumulator. Now I'll write the same thing. These two are examples for register addressing mode. Now one more thing, move A comma 90H. Move A comma 90H. 90 is the address of port 1. 90 is the address of port 1. So this instruction is as similar as move A comma P1. But what is the difference between move A comma P1 and move A comma 90H? Here in the second instruction, I am referring to P1 with its address. In the previous one, I am referring to P1 with its name. So this one is an example for register addressing mode. This one is an example for direct addressing mode. Okay, is it clear? So now coming to the next very important one, just have a glance at this. Move 0E0. 0E0 means A and hash 55. You are loading 55 in A. Move A comma hash 55. That is okay. Move 0F0. 0F0 means B register, comma R0. You are transferring R0 value into B register. But how are you referring to B here? With its address. What is the address of B? 0F0. Okay. So if you are referring to one register, one location with its address, such addressing is called as direct addressing mode. Now till now we have seen three addressing modes. One is the Okay, immediate addressing mode, register addressing mode. The next one is the okay direct addressing mode. The third variety is going to be little more tricky. So that is register indirect addressing mode. For that we take this example. There is one student. Okay, available in 51. 51. His roll number or her roll number is 20 or 27. We take 27. Okay. What is that 27? What is that 27? 27 is the roll number of the student. What is that 51? 51 is the class number. Okay. Now I am taking 51. What is that 51 there? 51 is the room number. I'm loading R0 register with room number. Now you just have a keen observation here. 51 and 27 both are numbers. I'm telling you 27 is a roll number. 51 is the room number, but both are numbers. Okay. Now I'm loading R0 with 51. In 51, there is a student by number 27 is there. 51 is a room number. In that room number, 27 is there. I want to transfer that student into room number 52. So I'm going to write an instruction MOV move 52 comma at the rate of R0. At the rate of R0. At the rate of R0 means whatever is there in R0, that is an address. At the rate of R0, that is an address. In that address, there is one number. There is one number. Okay. Transfer that number into 52 location. That is what it means. So observe this. We try to understand in our language. R0 is loaded with room number 51. In room number 51, there is a student by name, by number 27 is there. Move 52 comma at the rate of R0. What is there in R0? What is there in R0? 51. Is that 51 a roll number? No. Can you move room number 51 into room number 52? No. You are supposed to move the student who is there in room number 1, room number 51. So in room number 51, 27 is there. At the rate of R0 means that 27. Okay. Whatever is there in room number 51, that you bring it and put it in 52. Okay. So let us try to understand it in an easier way. Move a comma at the rate of R0. Whatever is there in R0, you consider that as an address. The content available in that location, you bring it, put it in accumulator. That is what it means. Move a comma at the rate of R0. At the rate of R0 means whatever is there in R0 is not the data. That is going to be the address. Okay. Of course, 51 and 27 both are numbers. It is my wish to consider 51 as the room number or 27 as the roll number. I decided I'm confirming. Okay. At the rate of R0 means whatever is there in R0, you consider that as an address. Okay. So what is there in R0? 51. What is there in 51? 51, 27. 27 is there in 51 room number. You transfer it into A accumulator. So that 27 will come in accumulator. That will come into accumulator. Okay. So that will come into accumulator. So that is what will happen. Sir, Is it compulsory to use only R0? You can use R1 also. Sir, is it compulsory to use only R0 and R1? Yes. Should not use any other registers. You should only use R0 or R1. Okay, so R0, R1 only are allowed to be considered in this type of addressing mode, which is called as register indirect addressing mode. You are referring to R0 for an address. You are referring to one register for the data. Okay, so you are referring to R0 for the 27. What is there in R0? Room number. Why are you referring to R0? For the 27. Okay, so you are referring to you want 27 to shift to 52. For that, you are referring to R0. So this particular thing is an example for register indirect addressing mode. You just see here, in register addressing mode. Yeah, you have to use the sign called as at the rate of move a comma at the rate of R0. Whatever is there in that location, you bring it and put it in accumulator. Move at the rate of R1 comma B. Whatever is there in B, register, you put it in a location. You put it in a location whose address is there in R1. Whose address is there in R1. So these two are the examples for register indirect addressing mode. Register indirect addressing mode. You're not supposed to use any other register apart from R0, R1 when you are using the register indirect, like move a comma at the rate of R2, not valid. Move a comma at the rate of R3 comma B, not valid. Move a comma at the rate of R0, valid. Okay, move a comma at the rate of R5, not valid. Only R0 and R1 are allowed. Okay, so such instruction is called as the register indirect addressing mode. The last one is going to be the see here move a comma at the rate of R0. Okay, so that is register indirect addressing mode. Now the last one is going to be the index addressing mode. Index addressing mode. So if you, yeah, this is the example for register or else index addressing mode. If you add data pointer with the accumulator content, then you will get one number. For example, I'm taking 1 in A. For example, I'm taking 1 in A. DPTR, I'm taking 9,000 in DPTR. A plus DPTR. How much it is? A plus DPTR. How much it is? How much is there in A? How much is there in A? 1. How much is there in DPTR? 9,000. The result is going to be 9,001. Okay. Move C. Move C. There is one special instruction called as move C, MOVC A comma at the rate of A plus DPTR. So at the rate of DPTR, how much is A plus DPTR here? 9,001. So what it will do is it will consider 9,001 like this. At the rate of 9,001, whatever is there in 9,001, that it is an 8-bit number that will come into accumulator. Okay, how did we get that 9,001? By adding A value with the DPTR value. If you add A value with the DPTR value, we got that A plus DPTR as 9001. At the rate of one address, at the rate of 9001 means whatever is there at 9001, whatever number is there at 9001, whatever content is there at 9001, you bring it and put it in accumulator. That is what it means. That is what it means. Okay, so this is an example for, okay, index addressing mode. So index addressing mode. How many addressing modes we have seen? Immediate addressing mode, register addressing mode, direct addressing mode, register, indirect addressing mode, index addressing mode. Okay, what is the example for immediate addressing mode? MOV A comma hash some number 23. 23. So you are trying to load 23 in A. Whatever data will be there in the instruction itself. Now, register addressing mode. Move R0 comma A. Whatever you want to whatever is there, the data is there in A, you transfer it into, okay, R0. Okay, so now move A comma 90H. There is one number available in location 90. There is one number available in location 90. You are trying to transfer that into accumulator. Okay, so register indirect addressing mode. Move R0 comma hash 51. Move A comma at the rate of R0. Whatever is there in R0, that you consider it as an address. So that is move A comma at the rate of 51. Whatever is there in 50 past location, you put it in accumulator. That is what that move A comma at the rate of R0 means. In place of R0, you are allowed to use only R1 or else R0. Not more than that. R2, R3, R4, R5, R6, R7 are not allowed. The last one is the register, that is the index addressing mode. Examples are if I'm loading A with, if I'm loading A with 1 and DPTR with 9000. Okay, A with 1 and DPTR with 9000. A plus DPTR is 1 plus 9000, that is 9001. Okay, the example is move C A comma at the rate of A plus DPTR. Okay, A plus DPTR is 9000. Move C A comma at the rate of 9001. Whatever is there at the rate of means whatever is there in that location. Whatever is there in that location. At the rate of 9000 means whatever is there at 9001 location, you bring it and put it in A. So this is an example for index addressing mode. So this is going to be one of the very important questions from Unit 2. Explain various types of instructions. Explain various addressing modes with one example each. Okay, so these are the addressing modes. Clear to all of you? So I'm just sharing the same recording, okay, in the